Hello everyone, I am Abdirizak Yussuf. I'm a student in the Math Stats department at St. Cloud State University. Today I'll be speaking on income inequality. In the last few decades, the U.S. economy transformed from pre-industrial colonies mainly dealing in farming to merchants competing in the trade of commodities to what we have today, corporations able to produce goods for a global market. The common theme being an increase in scale of production and also effectiveness in generating great revenue from smaller costs. So it's reasonable then that we expect this increase in scale of production be reflected in the income of the average person. In this project, I analyzed income data from U.S. Census Bureau to see if there's income inequality between income groups. The first thing that comes to mind is, why should I care? Some people think of income inequality as a philosophical or moral dilemma, and it's actually quite more than that. Income inequality is associated with societal problems like child mortality, political instability, and these are definitely detrimental to society. Having stated these implications, later I offered two remedies. I completed the whole project in R, and these are some of the packages I used. Mainly, I used the Tidyverse group of packages for organizing and visualizing the data. I used Reshape 2 for reconstructing the data, and also this unusual but interesting package I found recently called ck-means for univariate clustering. I got this data through the Tidy Tuesday project, but the original source is the U.S. Census Bureau. In this project, I focused only on two data, the first being income mean, which holds mean household income received by each fifth and top 5%. Some of the variables are year, dollar type. In our case, we'll only be dealing with dollar relative to that year. The second data I focused on is income distribution, which holds households by total money income. And some of the variables are year, income bracket, and income distribution, which is percentage of U.S. households earning that amount. By plotting the income mean data, the relationship between year and income becomes clear. We could see the mean household income increased for all groups over the whole period, but most dramatic is the increase for the top 5%, as well as the highest quintile, which saw a great increase also. In the previous slide, we saw the rate of change of income greatly differs for the income groups, but now if we plot the percentage change in mean household income, we also see that top 5% has twice the percentage increase than the lowest quintile. But also, if we consider the bottom 60%, we see they differ greatly from the top 5%, as they do not see the percentage increase that the top 5% sees. If we consider a slope graph of mean household income, and we look at 1967, all of the income groups are clustered together. None of them are making more than $30,000, and every decade it becomes more and more apparent that the rate of change differs for these income groups. And if we look at 2017, the bottom 80% combined do not make more than the top 20%. We have sufficient visual evidence now to prove the hypothesis mathematically. If we consider an analysis of variance model with an F statistic of 71.93 and a p-value less than 0.001, we reject the null and conclude that at least one of the 5 segments is significantly different from the others. By doing a Tukey pairwise comparison, we see that only 3 pairs are not statistically different. By looking at the p-value, we find what we suspected: the highest income quintile differs greatly from others. This is the unusual but interesting package I had mentioned in the 5th slide. It's unusual to me as I had never seen k-median or means with one-dimensional clustering. From the optimal univariate k-median clustering of income dollars, we find the following plot with 3 clusters. From the result, we get the following 3 income tiers, and this result conforms with policy institutes like Pew Research. If we project the income tier result we found back to the plot from slide 8, we get useful information. For example, this observation here represents roughly $35,000, which was the income of the second lowest quintile in 2016. And then this observation here represents roughly $35,000, which was the income of the highest quintile in 1977. Similarly, if we apply the income tier result to the income distribution data, we find there is only a slight increase in the distribution of upper income tier, but the lower income appears to be about the same. To conclude, it is apparent there's a difference in income for the income groups, and the rate of change of the highest income group is more rapid than others. I offer 2 remedies. We promote economic mobility by investing in schooling, especially for younger children, and we promote intergenerational wealth by lowering, for example, interest rate on home mortgages. I thank all of my professors at St. Cloud State University, and more specifically Dr. Lee, for showing interest in my project and encouraging me to submit it to this conference. It was in her class that I learned to make statistical arguments with R and presentations like this. This is my first conference, but it definitely isn't my last. Next, I want to thank the EUSR for giving me this opportunity, and I thank you for listening.